Mechanical properties of solids. Topic: stress strain curve. The relation between the stress and the strain for a given material under stress can be found experimentally. That is how strain varies with stress for a material can be found experimentally. In a standard test, a test cylinder or a wire is stretched by an applied force. The fractional change in length, that is the increment in length from which we can calculate the corresponding strain, and the applied force needed to cause the strain are recorded. The force is given, generally given in the form of a load at one of the free end of the wire. From that load, we can calculate the stress. The applied force is gradually increased in steps and the change in length is noted. Then a graph is plotted between the stress and the strain produced. A typical graph for a metal is shown. See, the shape of the graph may be different for different materials. That depends on the nature of the material. This is one of the particular graph for a metal. The stress strain curves vary from material to material. These curves helps us to understand how a given material deforms with the increasing loads. So to study the elastic behavior of that material, we will divide this graph into so many regions like OA, AB, BC, CD, D, and then we will study the graph in detail. So the portion OA, you could see there, it's a straight line. So in this region, stress is very small such that the stress is proportional to strain, which means Hooke's law is valid. The point A is called proportionality limit or limit of proportionality because above this point Hooke's law is not valid. That is, if you give a stress whose maximum value corresponding to the point A, then you could see that stress and strain are proportional to each other. That proportionality is maintained within this. That is, if you go beyond the point A, if the stress given to that material is above the stress corresponding to the point A, then we can't maintain the proportionality that is between stress and strain. So we call point A as limit of proportionality. So only in this region, Hooke's law is valid. Now, portion AB. AB is not a straight line, it's a curve. This region is reached if the stress is increased by a very small amount from the stress corresponding to point A. In this region, stress is not proportional to the strain, but once the stretching force is removed, the wire will regain its original length. That is, up to point B, that material maintains its elastic behavior. As you know, what is elasticity? That is, elasticity is the property by virtue that the body regains its original dimensions, original shape, original size, original volume, or its natural size once that deforming force is removed. That property is called elasticity. So up to point B, the material maintains its elastic behavior. So this behavior ends at point B, and hence the point B is known as yield point or the elastic limit of the material. Now portion BC. If the wire is stretched beyond the point B, that is above the elastic limit, the stress increases and the wire will not regain its original length after the removal of stretching force. So beyond the point B, as stress increases, strain also increases. But in between B and C, if you remove that stretching force, the body will never come to its original dimensions. That is, the body will have a permanent set. Its elastic behavior gets converted to a plastic behavior. Portion CD. With further increase in stress, the strain increases rapidly. You could see for a small stress, the corresponding strain is large. So, the strain increases rapidly and reaches the point D. Beyond D, the strain increases even when the load is removed and breaks at the point E. Therefore, the maximum stress, that is the maximum stress, that stress corresponding to the point D, beyond which the wire breaks, is called breaking stress or the tensile strength of the material. The corresponding point D is known as fracture point. The region BCDE represents the plastic behavior of the material of the wire.